Alright, ladies and gentlemen, in this video I just wanted to give you another example. I know I already have a video on mass, but I wanted to give you an additional example here in 2014 of how to do the mass problems so that you feel confident in doing the homework and that you're feeling more and more comfortable with this type of problem solving. The problem that I have up here is from the sample problems from lecture. Chapter 3, it is question number 5. So if you have this problem already written out for you, and it states how many grams of solid lead 2 iodide are produced from 35.0 grams of sodium iodide. So it's question 5 from the sample problems in lecture, and I am just going back one slide in my notes to remind you of how we do this sort of stoichiometry problem. This is the mass problem. Fundamental sequence of steps in a question like this. When you're given mass in chemistry, you want to turn it into moles, like 99 times out of 100. We do that via gram formula mass. That gives you moles. Moles are important because moles are how we compare things. We cannot compare mass directly. The coefficients in a balanced chemical equation represent moles. So we cannot simply take that mass and use that to compare. We've got to turn that mass into moles first. That's the first step. Once we have moles of the reactant, we can turn it into moles of the product using the coefficients. This is what we discussed in class, because the coefficients represent a molar ratio. So once we have moles, we can turn moles of one thing into moles of something else. And that's absolutely critical for us in chemistry. And then the final step, once we have moles of that new thing, moles of product, oftentimes the question will not ask you for moles. It will ask you to do something with the moles, meaning turn the moles back into grams. That's what we're looking at right now. And we do that with an additional step, and that's just using gram formula mass. Turn moles back to grams using GFM. So going back to this problem, how many grams of solid lead 2 iodide are produced from 35 grams of sodium iodide? So we've got our balanced equation. Balanced equation is given to us in this problem. Sometimes it's given to you, sometimes it's not. Interpreting the problem, how many grams of solid lead 2 iodide? Looking at this, our lead 2 iodide is right here. So we're looking for the mass of that. We're trying to figure out the mass of that. And it says we're starting with the 35 grams of sodium iodide. So we're starting with the NaI. This is a super typical problem in chemistry where you're asked about something that's on one side of the balanced equation, but you're not given any information on it. You do, however, have information about things that are not that, things on the other side. This is very, very common in chemistry. And the key to understanding how we get from one to the other is using coefficients, because the coefficients tell us the relationship between, in this case, the sodium iodide and the lead 2 iodide. So this is a 3-step problem. I'm going to do this as one long dimensional analysis T-chart. If you feel more comfortable breaking this up and doing it one step at a time, that is absolutely acceptable. I'm going to show it this way so that we start to get in the habit of writing it this way. But if you want to do it individually, you are not wrong. You can still follow along, you can still check your work, still make sure you're getting the same answer as I am. So the first thing that we want to do is turn this 35 grams of NaI into moles of NaI. And we do that using gram formula mass. So here's where we go to our periodic table and we look up sodium, and we look up iodine, and we take it to the 10th, and when we add them together, and this is something that you should check on your own, you should check to see that you're getting the same numbers as I am, that we get 149.9 grams is the mass of 1 mole of NaI. So right here, what we're doing in this step is we're turning grams into moles using gram formula mass. So that's the theory right there. Notice I did label this as moles of NaI right here. That I didn't just leave it as moles. And the reason I didn't just leave it as moles is because we're going to have moles of different things. So we're comparing moles of one thing to moles of something else. So I am actually labeling my moles just so we're being very, very clear about what it is that we're looking at. So this is that first part of the T-chart. We've done the first conversion. We've turned grams into moles. Now that we have moles of the sodium iodide, that allows us to do an incredible amount of things. Now in this problem they're asking us about the mass of the lead-2 iodide. In another problem might be something else. But once we have moles, that's crucial because now we can compare. Now we can compare the sodium iodide to the lead-2 iodide. And it's at this point where we go back and we say, what is the relationship between this and this? And that's based on the coefficients. So here's where the coefficients come into play. Coefficients represent moles. Now, I've got moles of sodium iodide on the top, so I want to put moles of sodium iodide on the bottom. Right, units cancel. And it's about turning moles of sodium iodide into moles of PbI2 because here coefficients allow us to compare. So this 2, it's just going to get put right in front of the NaI, and there's no number in front of the PbI2. No number in chemistry means 1 because chemists are lazy and we've got lots of invisible ones. 1 mole of PbI2. These are our coefficients. These allow us, this is where we are comparing moles. Moles of one thing to moles of something else. So here's where we're turning the moles of the sodium iodide into moles of lead-2 iodide. We're saying that we recognize that they are in a 1-to-2 relationship. So however many moles of the sodium iodide I have, that will create half as many moles of the PbI2, right? The 2 moles of the NaI create only 1 mole of the PbI2. That's our second step. That's that absolutely crucial comparison step. But we're not done with the problem because the question didn't ask how many moles of solid lead-2 iodide are produced. The question asked how many grams of solid lead-2 iodide are produced. So in our last step, we want to turn moles back to grams, but we have to be careful about what it is that we're turning back to grams because now here we've got moles of PbI2. So it's moles of PbI2 that will go on the bottom and grams of PbI2 that go on the top. So we do that using gram formula mass, but it's a different gram formula mass. Now it's going to be the gram formula mass of PbI2. We've taken care of the conversion for the sodium iodide, right? We're done with the sodium iodide now. All those units have canceled out. What we're left with is the moles of PbI2 to grams of PbI2. So now we want to really be focusing on that. So now we go back to our periodic table. Lead-2 iodide, look up the mass of lead, look up the mass of iodine. For every 1 mole of PbI2, it weighs 461 grams. Now we can do the math. Now, so the math we're doing, we're going to do 35 grams. We're going to divide that by 149.9. We're then going to divide that by 2, because that's where our coefficients come into play. That gives us moles of PbI2, but we don't want moles of PbI2, we want grams of PbI2, so now we're going to multiply by 461, because that's the mass of 1 mole. When we do that math out, when I do that math out, I get 53.8 grams of PbI2. Notice I am keeping sig figs into account. I am taking sig figs into account. 35.0 has got 3 significant figures, so I want my answer in 3 significant figures, and that's the mass of the lead-2 iodide that I can produce from the 35 grams of sodium iodide. I don't just take the 35 grams and immediately look at the coefficients and compare the ratio that way, because I need to turn the grams into the unit that the coefficients represent. The coefficients represent moles. I don't have moles, but I'm not worried because I got grams, and grams are super easy to turn into moles. So again, this is sample problem number 5 from lecture. It's just to give you another example of how to do this so that when you're going through the homework for 3B, you've got some examples to follow along with. Again, any questions at all, come see me.